This meeting is being recorded.
A very good evening.
Hi, Rabia.
Hi, hi,
Yeah,
Vinay. Hope you're doing well.
yeah, good, yeah, good.
All right, that's great. Okay. So today we are here for our last session on the topic backtracking. So we'll be completing this algorithm solving technique. So before we start, let me just brief what exactly is this backtracking technique and why is it utilized? So backtracking, it is a type of problem-solving technique or a problem-solving algorithm. What we do in this is we utilize this when we have to explore all possible outcomes or all possible solutions. So when we have a question, we don't need the most optimum solution. We need all possible solutions. In such scenarios, we use this backtracking approach. So we take a particular solution, try going deeper into it, and once we find an optimum solution, all right, we stay there and keep continuing to the next keep proceeding to the next solution. But in case we have reached a dead end, after that there is no possible correct solution, then what we do from that point of time, we go one step back and try to route or move into another route, that is move back, trace back our steps, right? So that we can explore other opportunities than what option we had chosen earlier. All right. So that is called as backtracking. Backtracking is nothing but you have walked few steps. Now you realized you're walking on the wrong path. So what do? You go back one turn, you go back one step behind and then check if there is any other possible road from there, right? So that's what backtracking is about. We keep walking on the path. If we hit a wrong end or a dead end or a wrong path, then we move one step back and from there we see what direction can be taken. Okay, that is what backtracking is. Now, what are the advantages of backtracking? So when it comes to advantages, it is the simplicity of the program. Why? Because we are doing it in the form of incrementation. We take one particular value, we increment it, keep moving, keep trying to find a solution. In case we don't get the solution, then we stop and move back. Okay, so it's a very simple approach. Then it is very optimum for problems wherein we have to find all the type of solutions possible, right? It is the right type of approach for problems where not only the best solution has to be found, but all possible solutions have to be found out. Then apart from that, it is very space efficient. So when we are talking about space efficiency, it's very much comparable to your dynamic programming, right? So it uses minimal memory, all right, and it uses recursion also. So apart from that, the disadvantages, when we are talking about the disadvantages, it is very difficult to design constraints that after this particular point, we don't want it to get into an infinite loop. We want it to stop, right? After completing certain number of steps, we want it to stop. We don't want it to continue back tracing. So designing that constraint to stop it is a little tricky. You need to design that very carefully. Then the second case is it uses recursion very heavily. Sometimes what happens is it might lead to overflow, right? If a no, if optimum celu if optimum back if op base case is not given in a correct way, if you have not given the constraint in a correct way, it might end up in a stack overflow. That is, it continuously goes on in a recursive loop. It does not stop. Then the other thing is, there is no guarantee for an optimum solution. We are trying to find all possible solutions. No one is telling here that whatever solution you're going to find is going to be the most efficient one. You are just finding out all possible solutions. There's no efficient solution here. And apart from that, it because it uses incrementation and it explores each and every element, so it becomes very, very complicated or time consuming for very large problems. If the problem is huge, it is going to take a lot of time to compute because it does it iteratively, right? So when backtracking has to be used for a very huge problem, it is going to be very time consuming. So that's also one of the disadvantages. So these are the advantages and disadvantages of your backtracking approach. So let us begin with it. I have few questions here and we can start with them. Yes. So Vinay, have you been practicing the LeetCode questions which were given in other topics? Did you get time or yet to practice it? What's the scenario?
Yeah, actually, I didn't get time because I
Okay,
was occupied with production defect fixing. So,
okay.
I mean, deadlines are very close.
All right, I understand. All right, so I think the approach has been quite simple, the approaches that we have completed so far. So, in case you encounter any doubts or anything, you can drop in a mail and I can reply over mail, right? Or LinkedIn, you have already tried sending a request. You can try it again. I have accepted your request though. No, I am following you.
Yeah,
Yeah.
yeah. Thank you.
So yeah, you can utilize that approach as well. All right, so let us begin with the questions here. So the very first question that we are encountering here is, we have an array of numbers given to us and they are distinct integers. Now we need to return all possible permutations. When we are talking about permutations, all possible combination that we can make with those numbers, right? That has to be returned utilizing the list of our integers, right? So from that list of integers, you need to make uh, whatever numbers are possible. But you can, one thing is you can return in any order. You don't have to follow any specific order that this number has to come first, then the second number, no order given. You can make any number of combinations and you have to return all possible combinations there, right? Not just the most efficient one. Anything that's possible with that number, you will have to return it. So here, what is the approach that we utilize? Assume that if we are having a number, for example, if integer is given to us with numbers 1, 2, and 3. Okay, we have number 1, 2, and 3. What are the possible permutations that we can create with this? So if we look at it, so one thing we can do is 1, 2, and 3. First number that we can create, 1, 2, 3. This is first number. Okay, so for this we didn't require any backtracking. We just kept started from this point and then kept adding the next number, whatever is there the index value, then moved to the next index value and added that number. That's how we got 1, 2, 3. Now, after this is done, let's start with, we have reached the dead end now. Now there's no further solution. So what we start here, from here we start backtracking. So when we are starting up backtracking, what do we first remove? We get rid of 3. So 3 is removed. Then we get rid of 2. Now 3 is removed, 2 is removed. We are left with 1 now. So with 1, what are the other approaches that we can take? We can add, we can keep 1 and after that we move to 2, right? So let's skip that branch and move to the other index value. What do we have? 3. Now the next approach is 1, 3 and then again what is the leftover number? 2 is leftover. So 1, 3, 2. This is another possible permutation. After 1, 2, 3 and 1, 3, 2, again let's backtrack. So now 2 is removed and we have 3, that's also removed. And again, with 1, there's no other possible combination. 1 is also removed. So now our path is empty. We don't have any path to move ahead. Next number we'll take. What is the next number? We'll move to the next index value. We'll start from the next index value. So we have 2 now. So we have taken 2. Then after that, we move to the next index. We get 3. So 2, 3 is one combination. 2, 3. And what is the other thing we can add? We have one more number left, that is 1. So 2, 3, 1. This is another permutation. Okay. Next, after that, what is the other approach that we can take? We can move to, we started off with 2. Instead of moving right, we can move I minus 1. That is take 1. So we started with 2, then we took 1, then we took 3. 2, 1, 3 is another combination. After that, again, with 2, we have reached the dead end. No further solutions with 2. So what do? We make 3 as your starting point. We start with 3 and then we take 1 and 2. So 3, 1, 2. Then again, we start with 3. Then instead of moving to the extreme left, we move one step behind. So what do we get? 2. So 3, 2, 1. So these are the possible permutations that we can make with this 1, 2, 3, utilizing your backtrace, right? So how did we backtrace it? We keep going further. We went to 1, 2, and 3, reached the dead end. We started moving one step back. First we moved back, removed 3. Then moved back, removed 2. Now with 1, what is the other possibility? Instead of moving to the next index value, we did 2 jumps. We moved to the later index value. That is, instead of moving to index value 1, we moved to index value 2 and we took the number from there. So that's how backtracking works. So these will be your possible outcomes. So let us write a program such that we can make this skip. We first reach the optimum solution and then keep skipping back. Okay. For that, what we are going to do is, first we have to keep track of your numbers, right? What are the numbers being added? So for that, we will declare one list called as path. Now this path is going to maintain where exactly are your pointers heading, what numbers are going to be stored. Okay. After that path, we will also utilize another thing wherein we have to stop. I told you there has to be a base case where your backtracking needs to stop. So where will we stop your backtracking? We will take the length of your length of your list. Whenever the length of your list is exhausted, we have reached the dead end. Then again, we start with your backtracking. So always your length of the array or your list is going to be the end point or the base case for your backtracking, so that it stops and does not end up in a recursive loop. All right. So let us first define a function called as permute. In this, we are going to be passing your integer of numbers. Okay. Sorry, integer numbers, the array that's given to you. So I am passing nums there. Inside this, I am creating your function backtrack. Backtrack. All right. Now this backtrack takes a starting point, takes two things. One is the starting point or your path. How exactly is your path going to move ahead? The second, it says that it needs to be distinct integers, right? So what we will do, we will make sure that there is no repetition. So we will have your path, as well as we will keep track of all the used numbers. All right, two things we will do. So in backtrack, we will first keep a track of your path and keep a track of the numbers utilized. Okay. So once I have passed that, now I have to check the length of my array. If we have exhausted all numbers or if my array is empty, then I am going to return, right? Not do anything, just return. So if length of my path is equal to length of my array nums, right? So if my path is equal to my nums, that is 1, 2, 3, how many numbers we have? 3. Now if my path is also having 3 numbers, then what do I do? Make that as my result, right? So that is obviously going to be my result because I have 3 numbers. So whenever you have 3 numbers, that means you have found one permutation and you need to add it to your result. So what will I do? I will use result dot append And what am I appending? I am appending the path. Okay. So path, but I am going to append it from the start. Whatever we are done with, next to it, again another path is appended. Next to it, another path, so on and so forth. It keeps going on. And then this we are going to be returning. Result only we are going to be returning. Okay. So this is the scenario. Now, how are we going to keep moving until we find the solution? Then when we hit the dead end, how to backtrack? Now the problem starts here. For that, I'm going to run your for loop. For I in a range, we are going to give the range. What is the range? The range is going to be the length of my array, right? Whatever is the length of the array, throughout that array, my for loop is going to run. So length of my nums, I am going to keep a track of my path as well as used. So I'm going to say if not used. If it's not present in your used array, then that I has to be taken care of. That is, it needs to be visited. So if not used I, then we are going to say used I is equal to true. That is, if it is present in used, then we are going to have the value as true. Okay. If it's not present in use, then we are going to represent it with false. So if used I is present, we keep it as true and we add it to your path. Path append uh, path append nums. We are going to add it along with your index value. Whatever index value it is, we will add it at that point, right? So then I told you that this includes recursion, right? So what happens in recursion? Recursion is a function which keeps calling itself until the condition gets fulfilled. So I'm going to call the function itself. So I'm calling backtrack. What are the two things we need to pass? Path and used. These are the two things to be passed. I am passing that as well. Then once we have the result in hand, I am going to pop it from my path. Path dot pop. All right. So now in case our used I, when it's present, it was giving true. If it's not present, then we are going to give it as false. Then we will give it as false. Now let us print the result. All right. So result is equal to, I am going to keep it as an empty list. And from that, I am going to call backtrack. That's the function backtrack. And then we are going to give the element where every false element is going to be multiplied with the length of my nums. False into length of nubs. So here, why are we doing this? So that in your used path, we start off with 3 false and then we keep replacing that false with true whenever the used is present in it. That's to make sure that we are having how many ever nums we have, so many false we are going to have at the starting point. After that, it keeps changing and manipulating when it moves to true or whatever it is. It's like a switch, on and off switch. But to begin with, we are going to start it off with false values. And those number of false are going to be equivalent to the length of our array. Okay. So once this is done, now I am going to return the result. Okay. After that, let us declare the numbers here. Here I am giving nums 1, 2, 3, and let's print the result. So print, I have to call my function permute and I have to pass nums here. So let's go ahead and print it. Here I've missed out a bracket. All right. So here we have the possible outcomes. We have 1, 2, 3. That's the first outcome. Then we have 1, 3, 2. Then we have 2, 1, 3. Then we have 2, 3, 1, 3, 1, 2, 3, 2, 1. All right. So how did this happen? Let me show you the backtracking for it. How exactly did it happen? First, two things it's keeping track of. One is the used and the other one is path, right? So I will represent used with U, okay? U is equal to, first, what do we have? In U, it told us that you are going to have the number of false as the length of the number. What is the length of the number? It is 3. So how many false we are going to have? We are going to have 3 false. F, F, and F. This is my starting point. All right. So after taking this as my starting point, now let us start with your very first number. What is the very first number? 1. So now 1, it becomes true. Your used becomes true, false, and false. That means for number 1, this is your used scenario. All right. So after this, again, go ahead, add the next number. What is the next number? We have 2. So for 2, 1 comma 2. Now it becomes 1 comma 2. So what does used become? It becomes true, true, and false. This is my used at this point of time. Then I'm going to add the third number also, 1 comma 2 comma 3. Now what is my used becoming? It is going to be 3 times true. True, true, and true. All right. So first element we have achieved. 1, 2, 3 is achieved. After this, now we start off with your backtracking. So we have added the result 1, 2, 3. Next, what do? We are going to nullify your two element from this. So true becomes false here. So now we have two truths, that is 1 and 3. So the next element we have is 1 and 3. Then we are going to add, in the next step, we will add the element which is missing, that is 2. So 1, 3, 2. This becomes our next, right? 1, 3, 2, done. Now both the combinations with 1 are done. Now we backtrack it. Remove 2, remove 3, remove 1. All three become false, false, and false. Now used is again back to false. Now we move to the next element. What is the next element that we have? We are going to consider your next element 2. So with 2, let's add 2. So now what did it become? It's giving you used as false, true, false, right? This is the next true. Now it is going to add 2 comma 1. It is making the left move. So what happened now? We have 2 trues and 1 false. Then again used is going to try to make this also true. So we are going to have 2, 1, 3. So all the 3 elements are going to become true, true, and true. This is how it is going to work. So you can see 2, 1, 3 is also done. Then we are going to get 2, 3, 1, then 1, 3, 1, 2, and 3, 2, 1. So on and so forth. It will keep moving. Your used is going to play a very big role in tracking what are the elements that are going to be added and what permutations are possible. Any doubts with this?
No, it's fine.
No? Understanding it.
Yeah.
Okay, perfect. All right, so let's move to the next one then. The next one that we have here is a combination sum. So in the combination sum, we have an array of distinct integers. Now these integers, they are known as candidates. All right, so we'll have a array called as candidates. Now simultaneously, we are going to have another number in a variable called as target. Now this target integer it can be a single digit or double digit depending on whatever is going to be given to us, right? Now the job here is, from that list of candidates, we need to find the numbers which are going to sum up to our target. Okay, what combination of those numbers, through what combination of numbers we can get that particular target or get a summation for that particular number which is stored in target. All right, now we can return any combination there. The order does not matter, but we have to make sure that the combinations are unique. We don't repeat the same combination and again. We can repeat the numbers, but not the combination. Okay. The combination of the numbers need to be unique. They cannot be repeated again and again. All right. So now here, let's assume if we are having a target of some, let me take target value as 7, and then I will declare candidates also. Candidates is going to be the list of my array or list of my numbers or integers, right? So 2, 3, 6, and 7. 2, 3, 6, and 7. These are my candidates, and we need to choose the combination such that it needs to sum up to 7, right? So the combinations need to be chosen in a way that it sums up to 7. All right. So let us start the function definition. So first, I'm going to be creating a function combine sum. All right. In this, I'm going to pass two things. One is going to be my candidates, and second is going to be my target. Okay. Both the things I've passed. Now I am going to declare a function to backtrack. So define backtrack. So in backtrack, I'm going to be passing three things. Last time what we did, we passed two things. That is, we passed your path and your used array or your list, right? In which we were keeping track. Here we are going to pass your start, okay? So that we get to know from which number we are starting to correlate, so that you can choose the combinations in such a way that it sums up to your target. So we'll give the start, then we'll give the path, and we are going to give the target. So at every attempt, we are going to we are going to find a new target, because once a number is added, what happens now? For example, if I have 2 added, okay, 2 is added after using start, 2 is added now. 2 is my starting point. Now, what happens after 2 comes into my list? Is target still 7? No, right? It becomes whatever is my start point, whatever is my number, minus the target value. Minus the target value, whatever is left out, that becomes my new target, right? So 7 minus 2, what will it be? It is going to be 5. So what is my new target? My new target is 5. Original target is 7. But to reach to 7, we keep decreasing the target so that we get such a combination which is going to sum up to 7. All right. So we are defining the start, then the path, and then the new target. These are the three things that we are going to be utilizing in this program. First, let us assume, to begin with, right, we need some instantiation or some starting point. If your target is equal to 0, in case it happens that your target is becomes 0, I told you that we keep reducing the target. So at a point where the target becomes 0, we have to stop your backtracking. So what will we do? We will attach whatever we have received. We are going to attach it as your result dot append. So in this, what are we appending? We are appending the path, right? So it's going to have a start and the end point. That's why we are using that colon. And once the appending is done, we are going to be returning it. Okay, so we will return it. This is the base condition, or this is the condition which is going to stop your recursion. All right. So once this is done, now I need to run the loop throughout your array, right? So for that, what do I do? For I in a range, I am going to give the starting point, and what is going to be the ending point? It's going to be the length of my candidates, or the candidates or the list or array of my integers, right? So length of candidates. Now, if candidates I, that is index value, whatever is there for that index value, whatever number is there, if that is greater than my target, if that is greater than my target, then what am I going to do? I am just going to continue. I'm not going to do any change. Just keep continuing the program, right? So then after we continue, let's assign that element with candidates I, whatever is that, I'm assigning it to the variable called as ele or element. And I am going to use path dot append and add this element there. So now it is added in the path. Once it's added in the path, again recursively, I'm going to call my backtracking function. And this backtracking function is going to take my index value. Then it's going to take the target. I always told you target is going to be changing, right? Once we have some first element in the list, the target changes to target minus I. That is your element, target minus your element. And we are also going to pass the path simultaneously so that there is no duplication there, right? It keeps a track of only numbers that are going to be unique combinations, no duplication of the combinations. So we are calling your backtrack application, backtrack function. In that we are passing the index value, we are passing the new target value by subtracting it from the current element and also the path that has been accomplished so far. These are the things that we are passing here. Now, after passing this, we need to look at the result, how to display that result, right? So I'm going to say result, I'm going to put up an empty list, okay? I have put up an empty list here. So after that is put up, let's call your backtrack again. So backtrack, we are going to start with 0. The path that we have here is going to be the target, right? And then the end is empty. We don't know what end it's going to have. So this is the way that I am going to declare or call my backtrack function. Then I will return the result. Okay, then I'm going to return the result. So we have the candidates here. Then we also know what is the target for it. So let us run the program. Let me run it again. Oh, sorry. I printed the target, but I didn't give print statement for the result. Print, I have to call combine sum, and in this I'm going to pass two things. One is going to be my candidates and the other is going to be the target. Let's run it now. Combine sum, candidates and target. Is it telling not supported? If candidates of I is greater than target, this should work. What happened to this? All right, let me just run it again. We have the for loop for I in range. We have the start. We have the length of the candidates. Then if candidates of I is greater than the target, then we'll continue. Then the element combination sum candidates, target, then the backtrack, start. Let's have it this way. We have target and then the start, target, and the path. If target is equal to 0, we are going to append your result to path and then return. For I in range, start combination. All right, now we have it. So now here in this combination sum, we are getting the output now. So what is the output that we can sum up to 7? 2 plus 2 plus 2 is 3. So 2 and 2 is 4. 4 plus 2 is 6. And how is it moving to 7? It should, no, it's doing the wrong thing here. Candidates and target. Then we have your start, the target, and the path. Then if target is equal to 0, result. Result dot append, we are having the path. For I in range, start, then we have your length of the candidates. If candidate I is greater than the target, then we'll continue. Element is equal to candidates of I. Okay, path dot append, we will select I, then path. Okay. After backtracking it, I also have to pop the element from the path. From the path, I need to pop the element. Only then it is not going to repeat. Here you can see that because it was not popped, it's repeating the same thing again and again. After we backtrack it, once its job is done, we need to pop it out also. All right, so now you can see there is no duplication. So we started off with 2, then we have moved to, we selected the element 2 now. So then we added 2 again, then we moved on to the next number, that was 3. So 2, 2 and 3 is going to give us the summation 7. Then 7 alone will be equal to 7. So that's how our combination here worked. Any doubts? Do you want me to re-explain this, or is this understandable? How exactly we did
Yeah, it's good. It's good.
it's good? All
Yeah.
right. Okay, perfect. Then we'll move on to the next question. So the next question that we have here is the subsets. So subsets as in, now consider we have a set here, a bigger uh, list of numbers. From that list of numbers, if we take few numbers from it, that becomes your subset, right? It becomes a smaller part of your set. That list or that array is your set, and taking some elements from it becomes the subset. All right, so here we are given an integer of array nums. Now that array can contain duplicates. Okay, there's a possibility that they might be duplicates. We need to return all possible subsets. Now the solution, it must not contain duplication in the subset. Your subsets cannot be duplicate. There can be duplicate elements in your list, but you are not allowed to have duplication for your subsets. We have to return the solution in any order. There is no specific order that's given. We can return it in any order. So here, first of all, we'll have one nums array. So in that, we will have some numbers. Maybe let me give it as 1, 2, and 2. Okay. And
Maybe,
we,
sorry to interrupt. Like we did like a target. We gave 7, and we gave some random numbers, and which gave the target a value or not with the constant, right? You gave like possibilities of it.
hmm,
The same way, if we give small alphabets and capital and other alphabets, and if
hmm,
I suggest one name like Vinay, so how many possible ways you can write in that thing like that? Something, any name or any iteration like. any two words letter something. So how many possible ways it can, like capital and small letter ones, capital and capital, small and small
Okay,
and
yeah. How many possible combinations or how many possible permutations it can make, right?
yes,
So instead of utilizing this, here we are giving target. We can utilize this permutations one. Instead of nums, we can replace it with a string, right?
yes,
So
yes,
that is possible. So then we are going to get all possible outcomes. It will give you without repetition whatever possible outcomes are there.
yeah,
The logic is simple. The logic is basically you keep whatever you have found at first, you will go ahead and print that straight off. After that, now there is no possibility of finding any further solution, right? You have reached the end point. There is no further solution from there. So what you will do, you will just move one step behind, remove one element from there, and then look at your string there if you can find any other possibility. No, still you cannot find any other possibility. Remove another element from that. Now you are left with only one element. From that one element, is there any other possibility? If there is a possibility, go ahead, do that possibility, and then kick out all the three elements and start fresh. That's how backtracking works. All right. So at every step, you are going to look forward. If you look forward, if there is a possibility, move forward. But if there is no possibility of moving forward, then move backward. Okay. That's what is your whole idea of backtracking. And it can be done with strings. It can be done with numbers, either of the way. All right, so when we are talking about the subset, we have to return all possible subsets from your major set, right? The set can contain duplicates, but your subset should not be duplicated, as in the order of your subsets or whatever subset you're taking, that should not be repeated again and again. It should be given only once. So now, first we have your integer here, the array of integers, nums, and in that you have taken 1 2 2. All right, so what do we do now? We need to keep a track of the path it's following, first thing. Then the second thing, we need to check the length of our array here, so that at a certain point your recursion stops. It does not keep continuing. Once we have exhausted the array, it needs to stop, right? So that is also going to be one of our conditions. So let us begin with the function. First, I'm going to define a function, uh, subsets with duplication. Okay, this is going to have your duplicates, right? I told you that the array might have the duplicates, so nums. Now, whenever we are having duplicates, how do we get to know if a duplicate is there or not? The easiest way is sort your list. Once you sort the list, if there are any duplicates, they would appear one after the other, right? So that would be there. Just give me one moment. All right. So it would happen, it would have one after the other, it will have the duplicate. So you'll get to know if there's a duplicate, you'll get to know where it is. So that's why make sure that once you have the array of integers, you sort it first, right? So before we call the function, we will sort it. But as of now, let's create your function backtrack. All right. So in this backtrack, I'm going to give the start point and I'm going to give the path. I'm going to keep track of the path as well as the start point. Now, once that's done, we have the start and we have a path there. We will just append it to your result, right? So result dot append path. In this path, we can have a start and the end range. So it will have more than one element basically, right? So it can either be an empty subset or it can have more than one subset of more than one element in that, or it can have all the elements in that. So all three options are available. So we have the result and we have appended it. Now we need to run this throughout the loop. So what do? We will have a simple condition there. For I in a range we are going to have the start, and we are going to run it throughout the length of the loop, throughout the length of the array. So array is nums. So for I in range, start comma length of nums. Now comes the condition. If your I, that is the index value, is greater than the start point. In the beginning, what's our start point? Start point is always going to be 0. If our I value is greater than 0 and your nums of I, that is with that index value, whatever you have taken, if the number in that is equal to your nums of I plus 1, that is if there is I minus 1, if there is a duplication, and if your I value is less, then you are just going to continue. No change, just keep continuing. Go through your nums array. Just keep going through, right? And then what will you do? You will add it to the path. Path dot append, whatever numbers you have found so far, you're just going to add it to your nums of I. You have not taken any action. If your I value is greater than start and your nums of I uh, is equivalent to a number before that, then you're just continuing appending your value to the nums I, right? That is appending it to your list path. Whatever number you have, you're appending it to the path. And then you're going to call your backtrack function, and in that I'm going to do I plus 1. What is I plus 1? I'm indexing, I'm increasing the index value. I plus 1, and then also passing the current path. In that current path, we need to add the next subset number. How to add the next subset number? I plus 1 I've done. Whatever number is there inside that, you can add that as your next value for the path. After that, from the path, I have to pop the elements, path dot pop, so that it makes space for the next incoming number, right? And it does not end up with duplicate calculation there. Then for first thing I told with your nums is to sort it. So let's sort it, nums dot sort, so that we get to know if there are any duplicates, it will be clearly shown. Then we are going to have your result, which is going to be empty in the beginning, and it keeps getting appended. Then I'm going to call my backtrack function, and here I have to mention the starting point, which I'm giving as 0, and path we don't know, so I'm keeping it as empty or null. Then we will return your result. Whatever result we are going to be getting, we are going to return that result. Then we have your nums. Let me call the function. So before that, print, what is the function now? Subset with duplicates, and in that I am going to pass nums. Print subset with duplicates, and I'm passing the number. Let's run it. Subsets. All right, so what are the subsets that we are getting? First, what did it say? Start dot path and result dot append path. For I in range, start is length of elements. Now, if I value is greater than start we are initializing with 0. Whatever I value, if it's greater than start, and your nums of I is equal to nums of I minus 1. We are just starting, we don't have a duplicate, so we continue. Path dot append nums of I. So very first number, what do we have? 1. So we start off with empty. Okay, so after starting off with empty, we are going to push nums of I 1 there. So after pushing 1, now we have to backtrack I plus 1 and put that as path. Now I we started off with 0. So 0 plus 1 is 1. Index value 1. What do we have in index value 1? We have 2. Is 2 greater than your start and nums of I? We just continue. Then we add 2 also. So now we have 1, comma 2. Okay, so first started off with empty, then we had one element, then we moved on to two elements for your subset. All right, so this backtracking is also complete now. Now next, what possibility do we have? We move to your I plus 1, that is third 0 1 2, sorry, 2, index value 2. What do we have in index value 2? We have number 2 there. So again we are going to have 1, comma 2, comma 2 added to it. Once this is done, now all the possibilities with 1 have been covered. Now we will move to index value 2. So now we have index value 2 and sorry, number in index value uh, 1, number in index value 1. So we have number 2 there. Now after that we have to uh, move and check with the next element. So we have 2, no change there. Then again we move on 2, comma, we come across 2 again. So 2, comma 2, 2. So these are the possible outcomes that we can think of when it comes to your subsets without duplicating the numbers with it. All right, this is an approach of your backtrack. Any doubts, do let me know.
No.
Okay, so here they have clearly shown we started off with 1, 2, 2. So start, we took it as 0. That's why we have empty braces, right? So empty braces you can see here, that's also one subset. After that, we start off with 1. We give start as 1, index value 1, and we start with 1. Then 1 and what is the next possibility? 2. So we add 1 and 2. Now after adding 1, we added 2 at the next point, and then after that 3 we added 1 2 2. But after adding 1 2 2 we don't have any possibility to move further. So what we do, we skip your first number. Now your start is 2 and we are taking number 2. So with number 2, what are the possibilities? 2 comma 2, that's it. Then again we go one step back and then move to the next 2. Next to, we cannot give uh, any kind of subsets there because it will lead to duplication. You can see the next digit is again 2, so it is going to lead to a duplication. That's why we don't move forward with that particular line there. All right, so these are the numbers that we have found that are going to be um, like ignoring the duplicates while calculating, and it's going to return all the possible subsets. All right, this is another important question. Do let me know if you have any doubts.
Can you try with 1 comma 2 comma 2? I mean, already it is there, and mention one more 2.
Okay, that is take it as 3 times. Okay, so here the second 2 we cut it off, the
In
third,
fact, 3 as well. After that, 2.
after this 2 you want to add 3 as well. Okay, so here the possibilities are, now here we took 1, all the possibilities with 1 we have covered. So once we have covered all the possibilities with 1, we start off with the second 2. Second 2 we cover all the possibilities that can appear, but we do not go with the next two 2's. Reason, they are duplicates. If we go ahead with them, we are going to get the same outcome as we got with this 2, right? So the starting point is 2 and then it keeps proceeding with the same outcome. So that's why we are going to skip the other two 2's and start off with 3. You can see here. So once all the possibilities of 2 have been exhausted, we are starting off with 3 directly. You can see this 3, right? So that's how it works. We do not process your duplication. So once duplication is encountered, it skips that, moves to the next. Again, if duplication is encountered, skip, move to next, and so on. So whenever duplication is encountered, skip it. That's the simple rule.
Thank you.
All right. The next question that we are coming across here is about a palindrome. So now what is a palindrome? Palindrome are strings which are the same when read from forward to backward and backward to forward. For example, we have M A L Y A L A M. Okay, so if you read it forward to backward, it is Malayalam. If you read it backward to forward, M-A-L, oh sorry,
Yeah, missed.
yeah, I missed out A there. Okay, Malayalam, M-A-L-A-Y-A-L-A-M, Malayalam. So when you read it from forward to backward as well as backward to forward, it needs to read in the same way. Those kind of strings are known to be palindromes. Do you have any other example in mind, like this Malayalam?
I.
Yes, good one. So E, Y, E. So forward to backward also it's the same spelling. Backward to forward also it's the same spelling. This is also a palindrome. All right. So now when you have given a string, you have a string S. Now you need to partition this string S in such a way that every substring, when you partition, you're going to get substrings. Now, whatever substrings you're going to get, when you join them back together, you need to get a palindrome. And they in themselves also need to be a palindrome. So those kind of possibilities or those kind of options need to be found. When you partition the string and join it back, you need to get back the same thing or same palindrome. And those substrings are also going to become palindrome. Clear? Any doubts with this?
No, no.
Okay, so now let us start with our program here. So, all right. So first, let us declare a string S is equal to AAB. All right, I'm declaring a string. Now, after the string is declared, let me create a function. So let's define the function as partition, and we are going to be passing your string there. All right. Now, after that, let us initialize your other function to check if it's a palindrome or not. Define is palindrome. So we are checking if the question that's been given is that a palindrome, right? So substring. All right. So we are passing a substring and telling if please check if this is a palindrome. Then we will return the results to the substring equal to substring minus substring minus 1. The return substring equal to substring minus 1. All right. So now this is done. Now we have to define the backtracking algorithm. So define backtrack. All right. So as soon as it's found a substring, you have to backtrack it and go back to the previous step and choose another alphabet and proceed from there. Okay. So backtrack, we have the start and we are going to have a substring. Okay. So we have the start as well as the substring or the, let's give this a simple terminology. Let's take it as the path. Okay. So now the backtrack function is going to have the start journey and the path the person is going to be following or has followed. All right. Start start, comma, path. All right. So once this is done, now we are going to see if your start is equal to the length, whatever length of your string is the start known. Then what we are going to do, we are going to add it to the result. Result dot append, and in that we are going to have the path. Okay, result dot append, we have a path now. So after that we are going to return. All right. So whatever we have got the result, we are going to be returning it. But in case that's not working out, then what we do, we run your for loop until the end in your range. Until the end in the range. How do we decide the range? Start plus 1 and then the length of the string and then add plus 1. All right, for end in range, we are going to increment your starting point, that is move to the next index and look for possibilities there. And then we are going to take the length of s and also add plus 1 to it so that you get the index count. You don't have to do it with your value there. You take the index count there. Okay. So once we have this, let us check if it is a palindrome or not. If is palindrome. Okay, if it's palindrome, then what do we do? We are going to have the string, then we are going to have from start to end. From start to end. Now, when we are saying this, we need to append your path. So path dot append and start to end. All right. So this is mentioned. So is palindrome, it's checking, then path dot append, it's checking. Then let us backtrack it. Backtrack. We are going to have end and a path. Okay. After this backtrack is called, we are going to be popping it. So path dot. Okay. So once this is done, we are going to be having the result. Pop. Now let's declare the result. Okay. So once the result is given, then call the backtrack 0, comma. Okay. So we have initialized the backtrack start point as 0 and then we keep incrementing it. And then let's print the return result. The return result. Okay. So we will have your result returned here. Now let us talk about the example. We already have the string. Let's print a participation s. Okay. And then I am going to print participation s, right? So we are going to be printing your participation S. Okay, so what happened? I've missed out the colon here. So if so now this should make sense. Participation partition. All right, so here what happened here, we are missing out some particular element. It's telling none. Okay, let's go through it again. So find the partition S. In that we are declaring a palindrome, which is going to take a substring. So we will return the substring if it's equivalent to substring to the extreme right. Okay, -1 is extreme right. Then we are going to define the backtrack. We will have your start and the path ready. After the start and the path are ready, if start is equivalent to the length of the length of your array, then you are going to add it to the result. That is result dot append path and return it. For end in range, start +1 is a good move to the next index value. Then we are going to have the length of your string plus 1. Now, if it's a palindrome, then you are going to have the start and the end. Now, if it is yet to be completed, then path dot append. We are going to append the path here, and we'll again have the start and the end point. Then simultaneously we are calling the backtrack and we are popping the element from there. So once we have this, we are going to look at the result. Okay. So here you can see that we are having first one that we are having is AAB, and then the second one is going to be AA and B. That is, AA is a palindrome. From anywhere you read it, it is the same. For B also, it is the same. So that way you have to figure out that where to exactly hit the partition. So after the partition, you can feel that the palindrome, you can feel that every partition is having a palindrome. That's when it becomes true that every subset is a palindrome. Clear? Any doubts?
No, it's nice.
Okay, so here they are showing you the working. First, AAB, it's the a string that's given, right? So first, what does it take? It takes A and it checks if it's a palindrome. Any character on its own is a palindrome. So that way, A becomes a palindrome. Next, after that, another element enters. A. So we have double A's now, definitely palindromes. Now after that, all three of them are together. B also enters. So now we have A, B. Here only B is not a palindrome, so we just leave that partition, then move ahead. In the next partition, we take your, instead of we take A, and then we take AB. Now, if we take AB, it is not a palindrome. So we do not consider this and we skip it. Next, after this, we are going to look at the double A's. Now, double A's are also a palindrome in itself, right? So double A's and a B separately can be uh, like taken into consideration and checked, because double A is also a palindrome and then AB is also a palindrome. All right. So we are going to collect all possible combinations and then print it. That's what we are doing in short. Now the next one is pretty interesting. So the next program that we have here is letter combinations of phone number. So we have been given a string containing numbers. Okay, now this string contains numbers from 2 to 9. So we are not using number 1 here, we are utilizing numbers from 2 to 9. And we need to return all possible letter combinations that the number could represent. Return the answer in any order. So we can return the answer in any order, but we need to figure out what possible combinations can be given for the numbers it selects. If it selects number 1, imagine your old telephone, right? This is how it looked like. It had numbers and alphabets both simultaneously. So here it's asking us to try and uh, like go find out the combinations of phone numbers that have that particular uh, knowledge, right? So now for one, we do not have a combination that can move ahead. So let's look at it from 2 to 9. So you can see in each and every button you have alphabets written. Now what do we need to do? We need to return all possible letter combinations that the number could present. So whatever combination the number can present, we are going to try and uh, keep that utilized, right? So first let me declare a variable with the digit. So I'm giving the digits as 23, and now it needs to make sure that this particular uh, this particular number is always going to have a translated version or the uh, alphanumeric characters with 2 digits only. Because we have the number as 2-digit number, the output for it also is going to be 2-digit alphabets there. All right. So we are going to try and recreate all possible letter combinations here, right? So now I have given it as 23. So when we are talking about 23, we're talking about DEF and DEF and ABC. We are passing 23, so 2 is ABC and 3 is DEF. So we need to figure out all possible outcomes between ABC and DEF so that there is no duplication here. All right, so let me give the digits as 23. Now in that, I am first going to declare a function. Define letter combo. Okay. And in this, I will pass it as digits. All right. So now if no digits are present, then we are going to return as it is. Then let us declare your phone map so that it becomes easier for it to understand. So phone map is equal to 2, and then when we are talking about 2, we have ABC. Okay, so after 2 we have 3, when we have 3 it's going to be DEF, then we are going to have 4, and this is going to have GHI, then let's do 5 now. So with 5, what we are going to be doing is, okay, with 5 we are going to utilize JKL, Okay, so with this, let us move to 3, 4, 5, 6, then 7, 8, 9, okay. Now let's type the alphabets related to it. For 6, A, B, C, D, F, G, H, I, J, K, L, M, N, O. Then we have P, Q, R, S. Then at 8, we have T, U, V, P, U, V. Then at 9, we have W, X, Y, Z. All right. So all the alphabets have been declared according to the phone key here, the phone map, right? So now let us try and create the logic behind it. So I'm going to have a backtrace design. Okay. In the backtrace, I'm going to pass the starting point, obviously. So let's give it as index, and then we have to obviously have the path also, what path it's moving. Right? So then if your index value is equal to your length of the digits, then we are going to add it to your result. Result dot append, and in that I'm going to join
Instead of
path.
instead of B, you mentioned N, A, B, C.
Join where, oh yeah, thank you, A, B, C. All right. So now here, what we did first thing after we started your backtrace, we are checking two values. One is the index and the next is path. Obviously, index matters because 0, 1, 2. And again, for the numbers also, if we have passed 23, 2 is 0 index value and 3 is 1 index value. Based on that, we are going to be picking alphabets from those particular numbers, right? And whatever we are getting, we are appending it to the result and also joining it in the path. Then let us return this. Now, once this has returned, for every character that exists in your map, for char in your phone map, what are you going to pass? You are going to pass the digits, whatever digits you have, right? 23 are digit. So the index value of it, you're going to pass the digit along with the index value. Then after passing that, whatever you get, whichever alphabet, you are going to append that to a character, right? So part dot append character. Then we are going to call backtrace again, and utilizing backtrace, you are going to be following the index plus 1 path. All right. So index plus 1 is going to help us move from one element which has already been printed to the next element. And then you are going to do pop also. You're not going to keep that in the system. So path dot pop. Now what I want to do is I want to give the result. So result in the beginning, it's going to be empty. Then call my backtrack. And in that, I want the starting point to be 0 and ending point to be empty. So backtrack is called, then I will call the return. the result. Okay, so return result has also been given. I have given the digits. Let's print the answer. Print letter combo in the bracket. All right, let's run it here.
You missed to mention S in the result.
Uh, which one?
Backdated 0, comma 1 is there, no? Above line.
Huh.
Above line. Above.
Okay, okay, this one. RESULT. None. Okay, something's gone wrong here again. So we started off with defining the letter combo. Okay, and in that I'm passing the digits. After that, we are telling if not digits, what happens? We are just going to return empty. Then phone map we are describing. In phone map, we have your number 2, which is ABC, 3 is EF, 4 is GHI, 5 is JKL, then 6 is MNO, 7 is PQRS, 8 is TUV, 9 is WXYZ. All right, so this is fine. Then we are going to look at the backtrace. In that we are passing index and the path. Then if your index is equivalent to the length of your digits, we are going to add it to the result. Result dot append. We have a join of your path, and then we are going to return it. Then for every character, for char in your phone map, digits and index, path dot append character. We are appending character and we are backtracing it as index plus 1 with path. Then path dot pop. Then result, backtrack, 0, comma, empty and return result. So this should work. It's giving none again. Oh, backtrace. Here I've given backtrace and here I've given backtrack. Anywhere else that I've given backtrack? Okay, here I have not done dot join. I have to do a dot join here. So whatever result we are getting, we are going to do dot join. Still it's not working for us. Any spelling mistake? Let me run it all again. Just give me a moment. I will. All right. Indentation was a little different. So here you can see we have two elements only, 23. So because of that, we are getting two letters only, because here we are matching your index to the length of the digits, right? So the length of the digits, we have 2 digits. That's why all of the answers here are 2. Now, how exactly is it working? We told 23. So 23 had ABC, 2 had ABC, and 3 had D, E, F. So what happened here? First, based on the index value, it picked out A, and based on the index value 0 and 0, D, AD. Then it moved to index value 1. So what did it do? It basically kept A as the same. From here, it moved to the index value 1, picked out 3. Picked out E. Then again, it kept A as the same, moved to the next index value, that is F. So AF. Now A, all the terms it's done, it has reached a dead end. Now it needs to backtrack. So what does it do? It removes F, E, and D, then it removes A itself. So once A is removed, move to the next index value. So we start with B. B and first element here, D. Then B and E. Then B and F. All right. All the elements for B are done. Now again, remove these elements and then remove B and move on to the next, that is F, right? Start off with F. Start off with C. So C, D. First is C, D. Then after that, C, E, and then C, F. So this is how you make letter combinations. Any doubt with this, Vinay?
No.
All right. So this is the last program that we had to complete based on your backtracking. All right. So if you have any doubts, do let me know. Else, this is going to be uploaded in the LMS, and you can try it out at your leisure, right? And then check if there is any trouble that you all are facing.
Sure. Thank you.
All right. Thanks a lot, Vinay, for attending this session. And please go ahead, keep practicing. LeetCode will help you a lot with cracking up interview questions, right? So hope to see you again for other sessions. Until then, all the best.
Thank you. Thank you so much.
Thank you. Bye-bye.
Bye.